Hello, welcome to this video. So this video will be about a conventional question in pair 1 of DSE about linear programming. So we are given part A, so we are given a figure about the straight line and then about the shaded region. Okay, so that will be about the linear inequalities in two unknown. In the shaded region, that will be the feasible region. And then we are asked to find the system of inequalities. Here, so already for L1, already we got the equation, and then from this, since you can see for this line, we want this region, so that's why you can see 0, 0 is also one of the points satisfying the desired inequalities. So that's why we just try to plus 0, 0. So 0, 900 is really less than or equal to. So that's why for the system of inequalities, so the first one, okay, would be 6x plus 7y less than or equal to 900. And then of course, okay, we have a y-axis. So y-axis on the right, so that's why x bigger than or equal to 0. And then this is the x-axis, so y bigger than or equal to 0. But we also need to look at this. So L2 totally on this side. So we need to find the equation of L2. So the x-intercept of L2 is 180. And L1 and L2 intercept at the point 45, 90. Good. So that's why here we need to find the equation of L2 first. So which is y minus 0 over x minus 180 equals to the slope, right? Because we got 2 points. So that would be maybe 2/3. So just 2x plus 3y, and then 180 minus 360. So in that case, we just try to plus 0, because 0 is also one of the points, okay, satisfying the inequality we want. So that would be negative 360, and 0 is really less than or equal to 0. So in that case, that would be 2x plus 3y less than or equal to 360. And that will be for part A. Okay, part B, here we go. A factory produced 2 types of wardrobes, X and Y. Each wardrobe X requires 6 man-hours for assembly and 2 man-hours for packing. And each wardrobe's Y requires 7 man-hours for okay. So and then in a certain month, the factory has 900 man-hours available for assembling. And has 360 man-hours available for packing. So and then profits of a wardrobe X and a wardrobe Y. So these two prices. So the total profit. Okay, so now first of all is about the numbers of wardrobes X and Y produced it. So that's why first of all in part B, let X and Y be the number of wardrobes X and Y produced it that month respectively. So and then the constraints. So first of all, X, Y are non-negative integers. This is the first constraint. And then we have, by looking at the assembly stuff, so here we have a 6x, and then we have 6x for assembly, and then 7y, okay, so and then total number of man hours for assembling all the wardrobes X and Y should be less than or equal to 900. Okay, so that would be the first inequality in part A. And then after that, we have packing stuff. So 6, 7, is that 6? No. For packing 2 and 3. And then altogether, less than, because 360 man hours available for packing, so that's why 360 here available, so that's why like this, and then you'll see there will be more or less the same as this. Good. So that's why you can see we can use the results, okay, in part A. And then after that, we try to denote total profit by P, and then PXY, we'll be looking at the second last sentence, so 44x plus 665y. So now by A, the vertices of the feasible region now first of all we have this is given, and for 0, 0, and then this is the y-intercept of L2, so y-intercept of L2, so that would be 2x plus 3y equals 360, and then since we are looking at y-intercept, so that's why 3y equals 360, so that's why 0, 120, and then finally there will be this point. That would be the x-intercept of L1. So x-intercept, so 6x plus 7y equals 900. So we're looking at x part. So that's why 150, 0. And then we just try to plug all the points in. Remember, it's plug all, not sum. Though, okay, some points, okay, would be, so by our mental calculation, they can be easily eliminated, but still we need to write them out. This is the conventional parts. And then the method, okay, by trialing the objective values at all vertices, okay, of the feasible region. So that's the method. Don't miss one of them out. Otherwise, you cannot get final mark. 79,650. So 0 is a gift, but still we need to write them out. So one by one, not missing any. Good, and then final one. So at last, okay, we can find out that the greatest profit equals 79,800, which is less than 80,000. So the worker claims that the total profit can exceed 80,000. That does not make sense. That's why the claim is discredited. And that's all for this part, as well as this video. Thank you for watching.